Okay, we are solving limits, and we're doing it numerically. This function here, which involves an exponential function, e to the 2x minus 1 over e to the x minus 1. Let's say we wanted to evaluate this function at 0. So we would plug 0 in, and we end up getting 0 over 0, which is undefined, at 0. And we'd like to probably know what would at least this be close to, right? Let's take a look at the graph. Okay, so here's the graph of the function e to the 2x minus 1 over e to the x minus 1, and we were plugging 0 directly into the function, and we were getting 0 over 0, which means that there's a hole right here in the graph. As you can see here, I've got it indicated, and we would at least like to know where is this hole located on the y-axis. And of course, if we take the limit of this function as x goes to 0, we can find out where that hole is actually located. So that's kind of the power of the limit. And we're going to actually do this numerically. We're going to pick some numbers to the left of 0 and see what their corresponding y value is, and then I'm going to get a little bit closer to 0 coming in from the left, and we're going to get a better approximation of what the y value is of where that hole is located. And then we're going to come in from the right hand side and do the same thing. Let's take a look at this table. So let's look at coming in from the right hand side. So I pick 0.1 and I plug it into the function here. 2 times 0.1 e to the 2.1 minus 1 over e to the 0.1 minus 1, and I plug that into a calculator, and I think I rounded to like 5 decimal places here or something like that, and I get 2.10517. Now we're going to get a little bit closer to 0 coming in from the right hand side, and I plug 0.01 in, and I end up getting 2.010005. So you can see here, as I get closer and closer to 0 coming in from the right hand side, I'm getting closer and closer to this number here 2. And then we do this coming in from the left hand side, so I'm going to go out and pick negative 0.1 and plug it in and plug it into here, right? And we get 1.90484. And I may have done some rounding here, chopped it off, but and then I get closer to 0 by plugging negative 0.01 in, and I get 1.9005. And so as you can see here, coming in from the left hand side, I'm getting closer to 2, and coming in from the right hand side, I'm getting closer to 2. Now if you really wanted to get as close as you possibly can to 2, maybe, I can't really say as close as you possibly can, but a whole lot closer, you could type in 0.00000001 right into here, or I should say negative 0.000001 into here, and we'd get even a better approximation showing that we're getting closer and closer to 2, but I just stopped at 0.01. Now we came in from the left hand side, and the way to express this as a limit, I've got a little negative sign right here. You can see the 0 with a little negative sign up here. So we're taking the limit as x approaches 0, right? And this negative means that we're coming in from this side. Okay, we're coming in from the negative side. And you can see this is called a left-handed limit, also known as a one-sided limit. Right, so we're coming in from the left, and we can say that it is approaching 2. Right, and this plus sign means that we're just coming in from the right-handed side, and the limit is also equal to 2. And if both of these numbers here are the same, then we can say then the limit as x approaches 0 is equal to 2. However, if these two numbers here are different, okay, then this limit does not exist up here. Limit does not exist. So this down here is known as one-sided limits. So we're going to actually show, as evaluating limits numerically, how to actually get this number without having to do this. However, if you forget how to calculate limits, you can always do it numerically, and at least you can approximate it and kind of pretty much guess, get a good guesstimation of what the limit's going to. So anyway, okay.